Today let us learn about remainder theorem. For that you need to know what a factor is. What is the literal meaning of a factor? Factor is a cause, is a component that contributes to a result, or in other words something small which results in something big. For example, if I say her hard work is a key factor in her success, that means what? She worked hard and ended up being successful. Similarly in maths, if I say 2 is a factor of 186, what do I mean? If I start with 2, I can find a number which when multiplied with 2 will give me 186. So now how will I find if it is a factor? What do I do? I will divide 186 with 2, divide and finally if I get the remainder 0, then good news, it is a factor. But if I do not get 0, that means it is not a factor. But then this is not what we do every time, right? What do? We go for the divisibility test. What is the divisibility test for 2? You look at the last digit. So if its last digit is an even number, then yes, 2 is a factor of 186. We can find a number which when multiplied with 2 will give us 186. Now, the same thing works for the polynomials also. Without dividing, we can find out if something is a factor or not. That is what the remainder theorem is about. Just like you have divisibility test for numbers, in the case of numbers, for the polynomials, you have the remainder theorem. Let us see what it says. Now, this is your remainder theorem. What does it say? You take a bigger polynomial. It should have one important condition. The degree should be greater than or equal to 1. It should be strictly greater than 1. That means do not consider 5 or 6 or pi. No constants. It should have at least one x there and a real number a. Then if px is divided by x minus a, what is x minus a? It is a linear polynomial, its degree is 1. So when you divide this polynomial by x minus a, the remainder would be p of a. Wherever you have x, if you put this a, that is going to be your remainder. So what are we doing here? We have a bigger polynomial, we have a smaller polynomial, we have to divide it and we have to know what its remainder is. Usually what do? We keep on dividing and dividing until we get a remainder, right? So here we are not going to do any such thing. Wherever we see x, we are going to put what? -1 and we are going to check. So wherever we see x, we are going to put -1. So -1 cube raised to any odd number, it will have a negative sign. Any even number, it will lose its negative sign and it will be positive. Again, an odd exponent raised to 1, raised to 3, all of them will always have a negative sign, and there its remainder is 0. See, good news. And what does that mean? If its remainder is 0, that means x plus 1 is a factor. Now let us see the advantages and the disadvantages of the remainder theorem. The first disadvantage, which both the divisibility test and the remainder theorem, both of them have, what is it? You cannot know what the quotient is. You have no idea. You just know what the remainder is. In both the cases, you have no way of knowing what your quotient is. So that is a big disadvantage. And what is the second disadvantage of this? It works only when your divisor is a linear polynomial, or in other words, its degree is 1. Your divisor should be of degree 1. That again is another disadvantage. But then what is the advantage of it? It will give you a remainder. For sure you will know what the remainder is. Is it 0 or is it 1 or 2 or 3, whatever number. And always remember, your remainder should always be less than the divisor. Even in the number, when you divide with numbers, you know that, right? Your divisor, your remainder should always be less than your divisor. Only then you can stop dividing. So it will give you a remainder. That remainder may or may not be 0, but it will give you a remainder. But in your divisibility test, you don't know what the remainder is. You can just look at this number and you can say what? 2 does not divide this. But then what is the remainder? You have no idea about that. But then your remainder theorem will give you a remainder. Whether it is +1 or 2 or 3 or whatever it is, you will get a remainder. That is an advantage that the remainder theorem has over your divisibility test. Now let us see 2-3 problems. Now what does this question say? You have a bigger polynomial of degree 2 and you have a small linear factor. You have to find the value of k. It is given that it is a factor. Then take the factor, find its 0. 1 is the 0 of this small factor. That means it is also a factor of this bigger polynomial. So wherever you see x, if you put 1, you should get 0. So try putting that. This whole thing becomes just k. This whole thing becomes just minus root 2 plus 1. If that is equal to 0, then your k should be equal to root 2 minus 1. Again, what do you have? You have a big polynomial and we want to find the remainder when it is divided by a small linear polynomial. There your bigger polynomial. What will be the remainder? Wherever you have x, you have to find the 0. What is the 0 of this? P. P is what will make this whole thing into 0. So wherever you have x, you put p, then you will get the answer. The first one will be p cube, the second will also be. Wherever you have x, you have to put p. Then minus p into p square will be minus p cube. Plus 6p minus p, your answer will be 5p. Now look at this question. You have two different divisions happening here. And look at the word respectively. What does it mean? The first dividend, the first divisor. The second dividend, the second divisor. Do not change them. So you have two polynomials px and gx divided by x minus 2 and x minus 3. So first dividend, first divisor. Second dividend and second divisor. Then what happens? They leave the remainders p and q again respectively. That means the first answer is p, the second answer is q. So you have two different dividends, divisors and remainders. But then these two remainders are connected by this relation. P minus 2q will give you 4. Then what is the value of this a? That is what we have to find. Now, if you divide any polynomial by a linear polynomial, what should be its remainder? Its remainder should be, wherever you have the x, you have to put this 2. That should be the remainder. But then we are given that the remainder is p. So let us first find out what happens if wherever the x is, if we put 2, then what is the answer that we get? Let us find that out first. Here, wherever the x was, I have put a 2. So this becomes 8a, this becomes minus 12 and plus 4. The whole thing becomes 8a minus 8. But then what is given? It is given that your remainder is p. So this becomes your remainder. Now next, go to the next division. What is happening with the next division? What should be its remainder? According to the remainder theorem, what should be its remainder? Wherever this is called g of x, right? In the g of x, wherever there is x, you have to put 3. That should be your answer. But your answer is given as q. Let us first substitute it here and then we will see. So this is what your g of 3, this is what you get. What is given? The remainders are given as p and q. But then applying the remainders theorem, you have found that this is what should be their original remainders. Now what is the connection between these two? P minus 2q should give you a 4. Let us find out what that answer is. This is your p and minus 2q. Okay. Now p minus 2q, substituting with the values of p and q, you get what? You get a is equal to 15. Now what do we have here? We have a big polynomial there, your dividend. And what is your divisor? It is a smaller polynomial of degree 2. Your dividend has degree 4. Your divisor has a degree 2. Now you have to show even without dividing. Do not start dividing. Show that this is a factor. How do you show that? First take the smaller one, your divisor, and find its roots. Now what are the two numbers which when added give you -3 and when multiplied give you 2? You can split it in this form. What are its zeros? The zero of this factor is 1. The zero of this factor is 2. Now if it is divisible, whatever is the factor of this should be the factor of the bigger polynomial also. So wherever you see x, put 1 and put 2. See if you are getting 0. If you are getting 0, then this is a factor. So see, p of 1 will be 0, p of 2 will be 0. So even without dividing, if the 0 of the divisor is the 0 of the dividend, then good news. What is the good news? It is a factor. Now that's all we have for today. Till I meet you next time, you take care. Assalamu alaikum.